Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. This lecture is for grade 10 subject chemistry, and in this lecture we will discuss chapter number 12. This is my 17th lecture, and here is your lecturer, Mrs. Saira Jamal. The name of this chapter is hydrocarbon. The topic which I'm going to talk about is about the general methods of preparation of alkanes. Like how can we prepare alkanes? So there are two important methods for the preparation of alkanes. The first method is reduction of alkynes and alkenes, and the second is reduction of alkyl halides. Like the common thing in these two methods are the reduction of alkynes and alkenes, and reduction of alkyl halides. What is meant by reduction? Reduction means gain of hydrogen. In this case, reduction is gain of hydrogen. Although reduction is gain of electrons, loss of oxygen, there are various definitions of reduction, but in this case, the term reduction means gain of hydrogen. It means that alkynes and alkenes after reduction means after gaining hydrogen will convert it into alkanes. So ethene has been reduced as it has gained hydrogen. So let us see the first method, which is the reduction of alkynes and alkenes. So you can see addition of hydrogen molecule across carbon-carbon multiple bonds. In alkyne, how many multiple bonds are present? So in alkyne, a triple bond is present. Triple covalent bond is present in alkyne, or in between the two carbon atoms, triple covalent bond is present. While in case of the alkenes, the two carbon atoms or the carbon atoms are attached through carbon-carbon double bond. So they are unsaturated hydrocarbons. It means that the reduction of unsaturated hydrocarbons will give us alkanes. Now, hydrogenation, this process in which reduction takes place, as in this case, hydrogen is added across carbon-carbon multiple bonds. So this process is also called hydrogenation, a type of reduction. And what is the name of this process? It is called hydrogenation because addition of hydrogen molecule across carbon-carbon multiple bond takes place. Hydrogenation takes place in presence of finely divided nickel at 200 to 300 degrees centigrade. Finely divided nickel means nickel acts as a catalyst, and the temperature required is 200 to 300 degrees centigrade and high pressure. So hydrogenation can also be done in presence of platinum or palladium at room temperature. Like if you want to do this process at room temperature, not at this higher temperature, because if you will use nickel as a catalyst, then to increase the temperature. But if you will use platinum or palladium, then you can do this process even at room temperature. You can see is this image that the carbon-carbon triple bonded compound is called alkyne, and which alkyne is this? Like as this alkyne contains two carbon atoms. So I told you for two carbon atoms we use the name eth. So this is ethyne. Eth for two carbon atoms, and I told you that for triple bond we will use the term YNE ion. So this is called ethyne. Hydrogenation of ethyne in the presence of nickel at 250 to 300 or to 200 to 300 degrees centigrade, it will give us ethene. Ethene means carbon-carbon double bond is there. So ethine after hydrogenation or after reduction in the presence of nickel catalyst and at high temperature and pressure is converted into ethene. And this ethene after further hydrogenation or reduction of this ethene in the presence of in the same condition like in the presence of nickel catalyst and at high temperature, it will then give us ethane. carbon-carbon single bonded compound is called ethane. So ethine into ethene and then ethene converted into ethane. This process is reduction process and it is also called hydrogenation because addition of hydrogen across carbon-carbon triple bond and carbon-carbon double bonds takes place. You can see in the product as in ethane, each carbon atom is attached with one hydrogen atom. But in ethene, each carbon atom is attached with two hydrogen atoms. It means hydrogen atoms are added with each carbon atom. And then from ethene into ethane, you can see the hydrogen atoms increases from 2, it increases to 3. Each carbon atom is now attached with 3 hydrogen atoms. So this process is called reduction of, the first is alkynes, and then alkynes are reduced into alkene and alkenes are further reduced into alkane. I told you in the presence of a nickel catalyst and at high temperature and pressure. This is the first method for the preparation of alkanes. The second method for preparation of alkane is reduction of alkyl halides. Again, the same thing. Addition of hydrogen is called reduction. So reduction means addition of nascent hydrogen. Nascent hydrogen means atomic hydrogen, like not hydrogen in H2 form, in atomic form, only H. Only H is called atomic hydrogen, or it is also called nascent hydrogen. And you know that atomic hydrogen is highly reactive because in atomic form hydrogen is unstable. In fact, it is a replacement of halogen atom with a hydrogen atom. Replacement of halogen atom with a hydrogen, you can see in this reaction, methyl, CH3 is called methyl because it is formed from methane. CH4 is methane, and the radical which is formed from methane after removing one hydrogen atom is called methyl. So this methyl and having bromine with it is called methyl bromide, and it is also called bromomethane. You can call it bromomethane. You can call it methyl bromide. So methyl bromide after reaction with nascent hydrogen, you can see this hydrogen is in the atomic form, not in H2 form, only hydrogen atom. So this is called atomic hydrogen or nascent hydrogen. Alkyl halide, because this is alkyl group, and halogen, ion of halogen like chloride, bromide, or any of the halogen atom, if it is present in the ionic form, in the bromide form is bromine here, so this is called alkyl halide. An example of alkyl halide is methyl bromide, or you can also call it bromomethane. Bromomethane, when react with nascent hydrogen in the presence of zinc in dilute HCl, so this is compulsory. Presence of zinc, powder zinc, and its solution in dilute HCl or any acid, it is compulsory because these two actually will give this nascent hydrogen. Because you know that hydrogen in atomic form never exists. It is highly reactive. It means for this reaction we have to produce nascent hydrogen, and then after production of nascent hydrogen, it will at the same time it will be utilized by this alkyl halide. So the production of nascent hydrogen in the reaction is very important. So this zinc in dilute HCl actually it produces this nascent hydrogen, and that nascent hydrogen then reduce this methyl bromide and will give, you can see this bromine is, or bromide ion is replaced by hydrogen. You can see carbon has 3 hydrogen atoms in methyl bromide, but it has 4 hydrogen atoms in methane. So it means that alkyl halides can be reduced into methane by using zinc in dilute HCl, because I told you that zinc in acidic medium will give this nascent hydrogen, or will produce this nascent hydrogen. And the side product, because this hydrogen there are 2 hydrogen atom, so one hydrogen atom, if it is it replaces the bromine, and the second hydrogen will react with this bromide ion to form hydrogen bromide or hydrobromic acid. This is one of the example, like alkyl halide, which contain one carbon atom, and the second example is the alkyl halide, which has two carbon atoms, or in other words, you can say that two carbon containing alkyl halide. So for two carbon atoms, I told you we use the term ethyl bromide, ethyl bromide, or you can also call it bromoethane, alkyl ethyl bromide or bromoethane or alkyl halide. Again, after reduction or after reaction with the nascent hydrogen will give us ethane and hydrobromic acid or hydrogen bromide as a side product. As I told you that this reaction takes place in the presence of zinc and hydrochloric acid. So why, as I told you, that it is compulsory, because actually zinc reacts with aqueous acid. Aqueous acid means the solution of acid in water. That may be hydrochloric acid in water, like dilute solution. When we make solution of an acid in water, it means it is a dilute solution, and we will call it aqueous solution. Aqua, I told you before, for water, and a solution in water is called aqueous solution. Aqueous acid to liberate atomic hydrogen. That atomic hydrogen is called nascent hydrogen. So nascent hydrogen reduces alkyl halide, like it added to the alkyl halide, because reduction I told means addition of hydrogen. So this hydrogen, when added to the alkyl halide, addition of nascent hydrogen is called a reduction. This addition of nascent hydrogen is called reduction. Now, how zinc when react with acid will give the or produces the nascent hydrogen? You can see zinc when react with the hydrochloric acid, it will give zinc chloride, and hydrogen gas in the form of H2 will liberate, and that H2 is actually there are two hydrogen atoms, because this H2 will decompose or it breaks down into two hydrogen atoms or into two atomic hydrogen atom, and those two atomic hydrogen atoms will reduce the alkyl halide. Now we have self-assessment exercise 12.3. Complete the following reactions. The first reaction is, you can see, as there is carbon-carbon double bond and three carbon containing compounds. So this is called propene. Prop for three carbon atoms, and ene when one of the carbon-carbon bond is a double bond. So propene, after reduction or after hydrogenation in the presence of nickel at a high temperature, will give us what I told you. Ethenes are converted into ethane. So you can see this double bond will convert it into single bond. And what will happen? The two hydrogen atom, one hydrogen atom will added at the first carbon atom, and the second hydrogen atom will add with the second carbon atom. So initially, if it has one hydrogen atom, you can see in product it has two hydrogen atoms, and the first carbon has two hydrogen atoms, and in the product it has now three hydrogen atoms. It means two hydrogen atoms are added with the two double bonded carbon atoms, and the double bond is now in this case is broken and converted into the single bond. So propene, after reduction or after hydrogenation in the presence of catalyst and at high temperature and pressure, is converted into propane. Propane. And if we have a propine, you can see there are three carbon atoms. So prop, same for these two compounds. But the difference is, in this case, carbon-carbon, one of the bond is carbon-carbon double bond. Keep this in your mind, dear student, that this is not compulsory that in alkenes all the carbon-carbon bonds will be double bond. No, at least one carbon-carbon double bond is compulsory. Same is the case in case of alkyne. At least one of the carbon-carbon triple bond is compulsory. It is not compulsory for the alkynes or for the alkenes that all of the carbon bonds will be like they may be uh, double or they may be triple bond. At least one is compulsory. If one carbon-carbon double bond is present, so that type of compound is called alkene. And if at least one carbon-carbon triple bond is present in a compound, so that compound is called alkyne. Reduction of alkyne uh, it will give us the propene. Propyne after reduction will be converted into propene, and then this propene you can see if further hydrogenation will takes place, then will convert it into propane. So this actually one more important thing is that for the reduction of propyne, as there are two pi bonds, and you can see one is sigma bond, and the remaining two bonds are called pi bonds. Pi bonds are weaker bonds, and they can decompose or they can broken down easily. So or they can be break easily. Now you can see, as they mentioned here, two hydrogen atoms. So we will do this reaction in two steps. First, we will do this step in which alkyne will be converted into alkene, or propyne after hydrogenation will be converted into propene. And then this step you have to write also that this propene after hydrogenation will be converted into propane. So this reaction, actually the final product of this reaction is this propane. Although the reaction takes place in step, first propyne into propene and then propene into propane, but in both cases the product will be propane in the first case and propane in the second case, because these two hydrogen atoms means that the reaction is completed in two steps. In the first step, the two hydrogen atoms will added, and the one bond will breaks up and will give, and then two bonds will left, and then the second hydrogen atom will be used to convert that or break one more bond, and then only one or single bond will be present between the two carbon atoms. So this reaction actually completed in two steps. The second one. Self-assessment exercise 12.4, complete the following reaction. This is the reduction of alkyl halide, and again I told you that reduction of alkyl halide only replacement of this halogen. Hydrogen will replace this halogen, and in this case you can see there are two hydrogen atoms attached with the carbon, but at the product side three hydrogen atoms are attached. It means the halogen is replaced. Instead of halogen, one hydrogen atom added, which is called reduction. So this is like you can say ethyl chloride or chloroethane is converted into ethane, and the side product is hydrochloric acid. This is the three carbon containing alkyl halide. We call it propyl chloride or chloropropane. Chloropropane or propyl chloride after reduction, and I told you HCl is not compulsory. You can use even sulfuric acid, dilute solution of sulfuric acid, because in acidic medium like these zinc react with an acid and will liberate this nascent hydrogen or atomic hydrogen. So this propyl chloride or chloropropane is now converted into propane, and the side product is hydrochloric acid. So these two reactions are the reduction of alkyl halide to give alkanes. Properties of alkanes, there are two types of properties: physical properties and chemical properties. So first, let us discuss the physical properties of alkanes. Alkanes are called paraffins. Alkanes are also called paraffins. Para means little and affines means affinity. So they have little or low affinity for other compounds, like they are less reactive. They are relatively unreactive because the valency of carbon atom is already satisfied. It already makes four strong bonds, four sigma bonds, four strong bonds. So this is highly, or they are highly stable compounds. So as they have little affinity towards reactivity, that's why they are called paraffins. Paraffin, I told you, little affinity or little reactivity towards other compounds. This term describes that alkanes show little chemical affinity or reactivity for other substances and are chemically and biologically inertly least reactive or less reactive. Alkanes molecules are essentially non-polar. I told you that organic compounds are non-polar in nature because there is least electronegativity differences between the carbon atom and hydrogen atom. So due to this least electronegativity differences, organic compounds are non-polar in nature. Alkanes are less dense than water and are insoluble in it. Definitely, if alkanes are lighter than water, so alkanes will float at the surface of water and will become insoluble in it. Another, why are they less denser and why are they insoluble in water? Because you know that the non-polar uh, solute, they are insoluble in polar solvent because water is a polar solvent. So according to like dissolves like, the polar solute will dissolve only in polar solvent. And again, why? What is the reason? You learn it in the grade 9 that there are two factors which decide the solubility of a solute in a solvent. And those two factors were, one was the nature of the solute and solvent, like either both are polar or both are non-polar. In this case, you can see alkanes are organic compounds and organic compounds are non-polar, while water is a polar compound. So nature is different. And the second thing is the type of intermolecular forces. And intermolecular forces like in case of polar compounds or in case of water, water has strong hydrogen bonding, and alkanes or the organic compound, they have weak London dispersion forces. So, like the intermolecular forces are also different. Nature of the solute and solvent is different. The intermolecular forces are different. So, due to these differences, alkanes are insoluble in water and are lighter than water. Second thing is chemically, alkanes are less unreactive toward most ionic compounds. Ionic compounds are polar in nature. That's why they are least reactive towards ionic compounds. This lack of reactivity makes them useful solvents. And due to this property that they are less reactive towards the ionic compounds, in most of the practical, then in most of the reaction, we use these alkanes as a solvent because they will not react with the solute and will not give us some other products which we don't require. You only need a medium to, like suppose if we are using paints and we just want to dissolve a paint in a solvent to make it thin, and then its application will be easy for us. So in that case, we are using only these solvents just to make them a medium, not to react with the solvent or paint it with solvent or give us some other thing or some other color product. We don't need it. We just need the same color, but only to make it thin. We use thinner or we use solvents, and mostly we are using these inert solvents because they will not react easily with the reactants or with the solutes. So that is the reason we are using alkanes as a solvent. For instance, hexane is used to extract vegetable oils from corn, soya beans, cotton seed, etc. The extraction of oil from these seeds, again, in this case, we need some solvent in which that liquid will mix, and then the collection or receiving of those oil from the seed will be possible or will be easy. That's why we are mostly using alkanes as a solvent. Alkanes containing up to four carbon atoms. Up to four carbon atoms, like like till butane. Butane has four carbon atoms. So means methane, ethane, propane, and butane. Till butane, these compounds are colorless, odorless, and the main thing is gases. Means methane, ethane, propane, and butane. They are gases. Then the compound which have carbon atoms more than or greater than 4, like starting from 5, pentane, till 17 atoms are colorless, odorless, but they are liquid. From carbon number 1 to carbon number 4, these compounds are gases, and from carbon number 5 to carbon number 17 are liquids. Then higher alkane means the compound which have carbon atoms greater than 17, like 18 and till onward, they are solids. And they are also colorless and odorless. This colorless and odorless is its property is same for all types of alkane. The difference is only that from carbon number 1 till carbon number 4, those organic compounds are alkanes. Our alkanes are gases. From 5 to 17 are liquids, and then from 17 till onward are solids in nature. Coming towards the chemical properties of alkanes, the first property is halogenation. As from the name indicated, halogenation means that halogenation means that substitution of hydrogen by halogen. Alkanes give only substitution reaction. Substitution means replacement reaction. Like one of the hydrogen of methane, it will be replaced by or substituted by chlorine or by a halogen. You can see here carbon has 4 hydrogen atoms, but like not in this case. In this case, it actually the halogenation takes place in two conditions. The one condition is in bright sunlight when we are doing the practical mostly at daytime, and the second type of reactions are when diffuse sunlight, like if we are doing the practical when the sunlight is not like very sharp or very like strong sunlight is not there. In strong sunlight, what will happen? The methane will completely decompose and will give carbon and hydrochloric acid. This reaction is when the bright sunlight is over there, or if we do the practical at daytime. So while in case of the diffuse sunlight, when there is not too much sunlight, or you can say if the practical is going on at night, or when there is very less light, so in diffuse sunlight, then substitution reaction will take place. Substitution means you can see that this carbon atom has 4 hydrogen atoms, but at the product side, it has 3 hydrogen atoms. Where the fourth hydrogen gone, the fourth hydrogen is replaced by one of the chlorine atoms. So it will give chloromethane or methyl chloride, chloromethane or methyl chloride. And one chlorine is left, and the hydrogen which is removed or eliminated from this methane, they will combine together and will form hydrochloric acid. This is the first step in diffused sunlight. Now, this product, which is chloromethane, the hydrogen of this methyl group can further be substituted or replaced by other chlorine atom or other halogen atom. Now, you see that the product which is formed in the first reaction, it is reactant in the second reaction, and this methyl chloride or chloromethane will react with second molecule of chlorine in the same condition like in diffuse sunlight, and you can see one more hydrogen will be replaced. Now here we have CH2, 2 hydrogen atoms are left, and one more chlorine atom will add. So initially it has one chlorine atom, now you can see there are 2 chlorine atoms attached with carbon atom. So one more hydrogen atom is substituted by or replaced by the halogen atom. Now this is called dichloro. Dichloro means there are 2 chlorine atoms. So dichloromethane. Dichloromethane is the product. Now, in the third step, this dichloromethane will be the reactant. And again, still it has 2 hydrogen atoms. Keep this in your mind, dear student, that this reaction will continue until all the hydrogen atoms of the methane are replaced by the halogen atom. So still it has 2 hydrogen atoms. Again, the same thing will takes place. Hydrogen will be replaced by one more chlorine atom. So chlorine, you can see the number of hydrogen goes on decreasing and the number of chlorine atoms goes on increasing. You can see 4 hydrogen, then 3 hydrogen. Then from 3 two hydrogen atom, from two, one hydrogen atom, and from one, no hydrogen atom. It means the number of hydrogen atoms goes on decreasing and the number of chlorine atoms increases. See, one chlorine atom increases two chlorine atom, then three chlorine atom, and then four chlorine atoms. So we can see that all the hydrogen atoms of methane are replaced by the halogen atom. So this substitution reaction in which the halogen atom replaced the hydrogen atoms of alkanes of methane one by one is called halogenation reaction. So when the one more hydrogen atom is replaced by the chlorine atom, this compound is called trichloromethane. There are three chlorine, so three chlorine means trichloromethane. And the common name of this trichloromethane is chloroform. You know chloroform, which we use for anesthesia purposes. So in the next step, this chloroform is the reactant, and again one hydrogen which is left will be replaced by another chlorine atom to give, as there are now four chlorine atoms, so four tetra chlorine chloro, and as it is replacing the hydrogen of methane, so tetrachloromethane, also called carbon tetrachloride. Tetrachloromethane or carbon tetrachloride is the name of this compound. So dear students, you can see that the hydrogen atoms of methane or alkane are substituted. By substituted means that hydrogen is removed and the place of hydrogen will be occupied by the chlorine atom. So replacement is called substitution reaction. Alkanes show a substitution reaction. And the halogenation, if the substitution is taken by halogen atoms, so that type of substitution is called halogenation. But halogenation, I told you, takes place in two conditions. One is in diffused sunlight. You can see in diffused sunlight, the substitution takes place in steps, and it will continue until all the hydrogen atoms of the alkanes will replaced by the halogen atom. And if the same thing like halogenation takes place in bright sunlight or direct sunlight or in at daytime, which is you can say explosive reaction, very speedy reaction, and what will happen, the methane will decompose into carbon atoms and the side product form will be hydrochloric acid. So alkanes give only a substitution reactions. What are substitution reaction? A reaction in which one or more hydrogen atoms of a saturated compound. Saturated compound, we discussed it before that all the compounds which contain carbon-carbon single bonds are called saturated compounds, or they are also called alkanes. So hydrogen atoms of alkanes are replaced with some other atoms, like in this case halogen. So this type of reaction is called a substitution reaction. These reactions are a characteristic property of alkanes. Alkanes react fairly with halogens in diffuse sunlight only, most probably in diffuse sunlight, and in dark there is no reaction. And in like completely dark, in diffuse sunlight, like if there is less sunlight, it will give product. But if there is completely dark, then no reaction will take place. In direct sunlight, reaction is explosive and carbon is formed which will deposit it. Then next chemical property or chemical reaction of alkane is combustion reaction. Combustion reaction, what is combustion reaction? So it is a reaction of a substance, which substance mostly hydrocarbons or alkanes with oxygen or air that causes the rapid release of heat. You know that the petrol, the CNG, we when we burn it, they are producing heat, and that heat we utilize for cooking purposes and for some other uses. It means that when these alkanes, when they react with oxygen or oxygen which is present in air, what will happen? They will release heat and the appearance of flame. They will produce heat, but that heat with a flame in the form of flames. That flame you can use for cooking food and for warming, like as a heater, etc., and for running the automobile engines. This process is called combustion. In simple word, you can say that the reaction of hydrocarbon with oxygen or with air to produce carbon dioxide, water, and a large amount of heat will release. This type of reaction is called combustion reaction. So complete combustion reactions are of two types: complete combustion reaction and incomplete combustion. Complete combustion reaction is the reaction in which methane, when react with oxygen, like oxygen supply is more. If there is excess of oxygen present in air, so like especially in at open atmosphere, it will give us carbon dioxide, water, and heat. But if the same reaction takes place at a limited oxygen supply, it will give us carbon monoxide. In incomplete combustion, methane gives carbon monoxide, carbon, and water. But in complete combustion, which takes place in presence of excess of oxygen, you can see per methane molecule we have two oxygen molecules. But in this case, per three methane molecules, there are only four oxygen molecules. So it means the supply of oxygen is limited. There is very less oxygen available, especially when the room is closed and the windows are closed. So in that closed condition, the oxygen which is utilized in burning process, so due to the less availability of oxygen atom, methane or the CNG or like the natural gas which we are using at home for the gas heaters. In that case, what will happen if in the room we are using gas heater which contain natural gas, and you know that the methane is present abundantly in natural gas. That methane will react with oxygen of the atmosphere or air and will give carbon monoxide and atomic, sorry, the elemental carbon with water. And you know that carbon monoxide is very poisonous gas. What will happen as the room is closed, the door are closed, the windows are closed, the carbon monoxide form will accumulate in room and then in turn may cause the death of persons who sleep in that room. So, but if the reaction, like if we are using the same natural gas and we burn it for production of heat to cook our food, in that case, as there is more oxygen, windows are open, doors are open, and oxygen supply is in excess. In that case, complete combustion will take place and will give carbon dioxide, methane will give carbon dioxide, water, and a large amount of heat will release because these combustion reactions are actually exothermic reactions. And exothermic reactions are the reaction in which heat is released. So combustion reactions are of two types: complete combustion, which takes place in the presence of excess of oxygen, and second type is incomplete combustion, which takes place in the limited supply of oxygen. Now, the lighter alkanes are widely used as a fuel. Lighter alkane mean methane, ethane, propane, butane, which has less number of carbon atoms. They are lighter. So the lighter carbon atoms, alkanes, are widely used as a fuel. This is because number one, their combustion can be controlled. We can control their use, same like we are using the uh, natural gas at our home, and its use is controlled. We just use the cylinder and fit it with our stove, and then we are using whenever we want, and we turn it off when we want, and like its use and the process is easy to conduct, so their combustion can be controlled. And secondly, they produce large amount of heat per gram, like the cylinder which we are using at home. We are using it like mostly for 2 weeks or more than 2 weeks, even we can, even for months, we can use that gas cylinder. So it is giving us large amount of heat for cooking our food and using it in our kitchen. So per gram give us a large amount of heat. And the third thing is they are cheap and easily available. So we uh, we prefer to use the natural gas or this LPGs, which are called liquefied petroleum gases, which also contain alkanes in it. We can usually uses these gases for as a source of heat. And incomplete combustion, I told you, will give us carbon monoxide, which is a poisonous gas. Uses of methane, where we can use methane. I told you that a domestic fuel, like in the form of sui gas which we are using at home, it contains methane, which is abundantly present in sui gas. Although ethane, propane are also present, but their percentage is very low. Compressed natural gas, which is called CNG, it is used as a automobile fuel, and this is again condense compressed natural gas, and natural gas is methane, which is an alkane. Also to manufacture urea fertilizers. For production of fertilizers, we are using methane, and to manufacture some important chemicals such as methyl alcohol, methyl alcohol, chloroform, carbon tetrachloride, all these products we can obtain by the halogenation of alkanes in diffused sunlight. We can get these important products. I told you methyl alcohol, chloroform we use for anesthesia purposes, carbon tetrachloride we use as a solvent. So these are very important compounds, and they have very important uses in our daily life. So hope you, dear students, you understand the uh, how to prepare alkanes, preparations of alkanes, the two methods we discussed, and then the properties of alkanes, physical properties as well as their chemical properties. And in last, we discussed about the uses of alkanes, like the most important example of alkane, methane, we discuss its uses as well. So hope you understand it. Inshallah, in our next lecture, we will discuss the next hydrocarbon, that is the unsaturated hydrocarbons. Till then, take care. Allah.